Greetings, class, and welcome to this lecture on network security. We are in, let me just take a look, if I get the right class here. We are in chapter 12 of the text, which I believe this is week 11. So let's double check here real fast. Don't want to, or unit 11, I should say. Yeah, unit 11, chapter 12, and on network security. So we're going to go through these slides, and we'll also look at a couple of assignments here, or one of the assignment here, I should say, that will be coming up here real soon. But in essence, this is kind of the bread and butter of this class. And that is, how do we defend a space, that being a network, a system, etc. So I'm going to share my screen. There we go. So the objectives of this chapter are to basically be able to identify certain network attacks and certain network defenses, the protocols that are vulnerable generically, design of networks that help us with network defense, and tools that will help us assess network security. So let's talk a little bit about design first. So being able to segment your network off into different parts where assets are placed in those network segments that may be more either vulnerable or seen as more risky, or to make them risk averse. We do that by segregating them based on role, right? We talked about role in servers previously. So certain servers that need to have or be able to face the internet versus servers that just rely on communication internally with internal users, and separating them out so they're not on the same network is very, very, very critical. We do this by leveraging a demilitarized zone, or DMZ. It contains those systems in a what they call a less trusted area. What does that mean? That means they have to face the internet. All right. They still need to be behind a firewall and security controls, but they are not assets that don't need to face the internet or don't need to have interaction with users, devices, APIs, etc. on the internet. Intranets is where those servers would fall. They basically are there just for internal users. This would be Active Directory controllers, certain file servers, database servers, etc. Servers that would go onto a DMZ would be things that would interact with internet devices or internet requests, such as web servers, DNS servers. Those are the two that really come to mind. If you were still housing your mail internally, it would be your SMTP gateway would be on the DMZ, and any other type of server that you would want to segregate out, that you want to really observe that traffic. FTP servers, remote access servers, VPN servers, those things would definitely be on DMZ. Extranets are those networks that are set up for external access. So these are networks that you're going to have with a business partner, all right, or community partner of some sort. And typically how you connect to them is through a site-to-site VPN. Network access control focuses on us determining whether a system or device should be allowed to connect. And network access control can be done from the external part of the network. It can be done from inside the network. It has matured over the last 15 plus years. I remember when NAC came out and it was not ready for prime time. Cisco Systems had a very early on product, and it took you literally months to implement it. Now they have redefined that process. It is a lot easier. It's easier to define and regulate devices that are entering or exiting networks, and migrate them to network segments where, if they are at risk, they can be placed on a network segment that is low risk, i.e. a DMZ. They basically do this by checking these systems. So if you plug in a device into a network, or you join a network via wireless, and you may get a pop-up in your browser when you try to join, it will give you some terms and conditions. If you click yes, you may be allowing whomever to scan your system for things like, is your antivirus or endpoint security up to date? When was the last time you did a scan? What software are you running on your system? Is it up to date? And it goes through these checklists. And if those checklists check out, for lack of a better term, you're allowed on the network. If they don't, they warn you, and they typically can tell you, hey, you need to update your Java, or you need to update your browser, or you need to update XYZ. When you do so, come back on and join our network. They've gotten a lot better about doing that. Port security and port level protections. So this is done, again, we're talking about layer 2 port protection. We're not talking about TCP or UDP ports. We're talking about layer 2 physical switch ports. Layer 2 security is very important. It is one of the areas of security that is often overlooked by junior or inexperienced network engineers. What we want to do is we want to ensure that no layer 2 loops get injected into the switch fabric. That would be bad and cause a denial of service. We want to prevent broadcast storms, because that can degrade connectivity. We want to set up bridge protocol data unit guard, which basically works to prevent loops and also works to prevent rogue switches from joining the network. And then we want to set up dynamic host configuration protocol snooping, which will prevent a rogue DHCP server from passing out IP addresses on the network. There are two other things about layer 2 that we need to touch on: the port mirror and the span port. A port mirror basically sends a copy of all your traffic sent to one switch port to another switch port. All right. This is a general basic way that we can dump traffic to a specific device. So if we set up a Wireshark laptop, we can do that with a port mirror. What a span port does is it can do the same thing, but it combines traffic from multiple ports, or even VLANs, a single VLAN or multiple VLANs from multiple switches to that one port or ports, so that they can grab a lot of traffic. We see this done with SIMs, right? That have a sensor, and then that sensor reports back to a controller, maybe on a separate NIC, and a back-end management network. So understanding VPNs, again, we kind of talked about this in cryptography a little bit. But there are two types of VPN technologies: IPsec and SSL TLS. IPsec is harder to put together. It's harder to set up. Excuse me. It's easier to set up. It takes a lot more time for the end user to learn how to use it, because you're using typically a separate program or application. That's gotten easier over time, because as apps have gotten easier for individuals to use, and as we get used to using apps on our phones and our computers, this has actually come down a little bit. But SSL VPNs are really easy for end users to use, because they can basically just use a web browser and put in a username and password. They do it every day for so many different types of applications. Those are harder to set up for the administrator, believe it or not, because you're dealing with certificates and you have a lot of back-end work as to what users can get to what assets and what network segments. You also have two implementation decisions, whether the remote access is going to be a regular remote access, like what we just described with those two, or site to site. And this is just, what is the purpose of the VPN? Is it to get people into the network so that they can do their work? Thank you, COVID, for expanding upon that, 1,000-fold. Or is it a site to site? Is this a business partnership that we have with another organization where we need to share resources? And then you have split tunneling or full tunneling. This is a simple concept. Basically, a split tunnel is where the remote access user retains access to their local internet. And if they go out to the internet, they do that from their local internet connection. Full tunnel means you're using the internet at the remote site or at the VPN site. So your VPN tunnel sets up, and then you use the internet connection at where you're tunneled into. That's all that is. Now, it's a lot faster and more efficient to do split tunneling. It's more secure, and you can monitor much better if you do full tunneling. Those are the big differences between the two. Network appliances and security tools, there's a bunch. So these are in your book. I would go ahead and read through each of these and have an understanding. There's a lot of questions that can be pulled up on your quiz and exams for them. Some of the main ones that you really need to look at from a security side: proxy servers, load balancing, IDS, IPS, which we've talked about previously, of course, firewalls. UTM stands for Universal Threat Management. Security applications and architecture is really coming into its own nowadays, to where you have security solutions for entire enterprises. So let's talk a little bit about IPS and IDS. Intrusion prevention system versus intrusion detection system. An IPS will do everything that an IDS can. Okay, an IDS is just there as a tripwire. It is there to alert you, hey, something bad's happening. It is signature based. It will only alert you for the most part. And it runs off of a sensor, typically. Now, an IPS is typically an inline device. Now, it can be part of a firewall system or appliance, and it can take action for you as you define it. So if it comes across a bad TCP connection, it can reset that TCP connection or close it down, or write an ACL to prevent future connections. It basically can also examine traffic in the packet, or what we call deep packet inspection. IDS just looks at TCP, UDP, IP, ICMP, GRE headers, and they don't look at the data. An IPS you can configure to do so, and it can pick up on bad stuff that is happening from within the packet. There are several different network security services and management systems out there. Some of the ones that we're going to kind of concentrate on here for the rest of the course is going to be out-of-band management, SIEMs, and firewalling. ACLs, access control lists, are the primary function and feature in a traditional firewall. This blocks access either into or out of the network based on what you define. So here you see a couple of rules here where they have the first one, rule number 10, is for SSH, where it is going to allow connections to the 10.0.10.0/24 network, and so on. Deception and disruption. So I wish we had time on our hands as security professionals to do all this work with honeypots and honey nets and honey files. And there are some good products out there on the market that will do that for you. but they're expensive, and management typically is going to go, well, why do we need that? For 99% of the companies out there. Now, for that last 1%, it may behoove you to do stuff like this, especially if you are in the security space, like at a Cylance, a CrowdStrike, or Rapid7, and you're analyzing hacker behavior, then yes, you'll definitely work with honeypots. But if you are on the defensive side of the house, not the IR side of the house per se, you may never ever work with a honeypot, honeynet, or honeyfile system ever. Now, they're fun to play around with. They're really kind of cool because you can look at behaviors and tools and collect all kinds of data. But practicality, and especially from a capital expenditure standpoint, they're a hard sell. All right, so the protocols that you have to look at as to what you want to defend in a system are very common, and they're going to be repeated across all industries, businesses, organizations, etc. Here are the top ones: DNS, FTP, HTTP, IMAP, LDAP, POP3, and so forth. They have secure brethren, or brothers and sisters that are out there. So DNS, we can use DNSSEC to secure it. Basically, we can encrypt DNS traffic between DNS servers. FTP, we can use SSH and use file transfer across SSH, or FTPS as well. HTTP is the easy one. We can use HTTPS on port 443 and use certificates and make it happy. IMAP, we can use secure IMAP. LDAP, we can use secure LDAP. POP3, we can secure it across a different port and encrypt it using, again, most all of those using TLS. RTP, we can use secure RTP on a different UDP port. Again, it will be authenticated or encrypted. SNMP, we would use SNMP that does do encryption and authentication. Right. And obviously the granddaddy of them all, we should not be using Telnet anymore whatsoever, ever. It's clear text, it's easy to read, it's easy to intercept, and we should be using SSH. So the secure protocols that we really have to concentrate on are when we are transferring files, email, or using VPNs with IPsec. A couple of different types of attack are either man in the middle or direct sniffing attacks. We see the direct sniffing attacks here, where we have an attacker control system that's in the middle, or we're able to directly put ourselves within the path. That's how we do that. DNS, it's not too hard to do that with, because DNS is very open for requests. In layer 2, this is easy as well, because layer 2 is, by itself, really easy to manipulate, especially if you can plug in a system into a port and you have a MAC address. You can start sniffing around. ARP is not controlled, and escalating to get IP information is not terribly hard. We can do that by MAC cloning to steal IP addresses or duplicate IP addresses. A distributed denial of service attack is basically either operational or network-based. So operational is where you go after one single port. So I'm just going to go after port 443 against that web server and try to take that website down. If I go after a network-based attack, I'm going to try to take the entire network down. You see less of the network-based DDoS attacks and more the operational-based DDoS attacks these days, because bandwidth is so cheap and so fast, you really can't do a lot of network-based DDoS attacks anymore. The next slide, they kind of look at the SYN flood on a switch. Okay, so let's talk about reconnaissance and discovery. Routes, DNS information, and network paths. This is how you can not only figure out the path that an attacker may be taking, but also to help you troubleshoot in case you have any type of a routing issue. Here's a standard trace route back to the publisher's website. And as you can see, it traces several hops from wherever the end user was, back to a certain IP, and then you get a lot of requests timed out. So what these are, these next 8-10 hops here, they're blocking ICMP basically. They're not allowing you to see it. So these might be internet POPs, internet addresses from service providers. And then when you get to a specific IP, you may not see anything on the interior of a private network, more than likely at Wiley, the network of wherever Wiley.com is, until you get to the server or whatever is hosting that service. Routes DNS information, a sample path ping to Wiley. A path ping is going to give you a site by site breakdown with microseconds and tell you how fast it is between points. Some tools that you can use for troubleshooting and understanding these networking concepts, which are very important. IP config, you need to know what your IP is. Netstat will look at what services are being hosted by your system. ARP will give you layer 2, sometimes layer 2 to layer 3 information, and route will tell you where your default gateway is and print up your routing table. Yes, servers can have a routing table. Is that practical? Not ever, unless you want to build your own router and have multiple NICs in it, or you build your own firewall and have multiple NICs in it. I've seen people do that. They have fun with it. It's a great garage, hobby to have. Is it really good for production? Not really, not so much. Not since like the 1990s. Port and vulnerability scanning. So here they are basically looking at Nmap. We've talked about Nmap previously. It should be kind of a review. If you just a quick note here, if you ever pull up an Nmap scan and you see all of these ports open, you really need to scratch your head and go, why am I seeing all these ports open? What is on this box? What is this box doing? Because that's a telltale sign that you need to dig deeper and find out the purpose of this server or this device. All right, data transfer. This is really fun because Netcat, curl, and hping can allow you to do a lot of different things, especially around privilege escalation or backdooring, etc. So more on these in the 4710 class. We get a little bit more in depth with them. Another thing that offensive security practitioners do is the open source intelligence steps. This is where we pull information via open information that's on the internet, free, available to anybody, not breaking any laws here. You're just going after what information people are putting out there. And you would be surprised at how much information people put out there that can be used against them. So a good program that they have, the Harvester, you can pull a lot of information off of a domain. That's what they're doing here with Wiley.com. DNS enumeration or DNS enum does the same thing. It's going to pull information out of the DNS system about a domain. TCP dump will help you out with port scanning or with process trailing. TCP dump is the basic underlying engine of programs like Wireshark. And it's used a lot with things such as tail, commands such as tail. Wireshark is its own separate program. You should be very familiar with it, hopefully by now, to capture information off of an entire network segment, not just a single device, which basically TCP dump is for. The concept of sandboxing is really interesting because this is a new technique where we can actually fork traffic off into a sandbox. And I shouldn't say new, it's about 12, 13 years old. That sandbox is typically a VM, and then we take that traffic and we analyze it. We may take that traffic and put it towards a device that is similar to the destination. What is it doing? Is it malware? Is it a virus? Is it a code injection attack? What we can analyze it. So you see sandboxing that can be done inside of a firewall appliance. You can see it done in a honeypot. You can see it done in a lot of different places. The problem that we have in the industry is who's watching it. We have barely enough people now that we can do incident response with after the fact, reactively. Doing this type of proactive security, which I'm all in favor for, is the next step in our industry. And that's why one of the reasons I think we have a lot of job openings out there is companies want to do this kind of work. They just do not have the resources to do so. All right, so that kind of completes the lecture here for today. One sec. Let's go back to unit. I'll get it right here in a second. All right, so unit 11, we just have a quiz this week, so make sure that you work on that quiz, and next week we'll get into wireless and mobile security along with homework 8. So I'll talk about wireless and mobile security then. Until then, have a great week.